So welcome everybody. Today's class will be on AP Calculus, where I will be discussing a few more questions on AP Calculus. The last class I had discussed questions 1 to 7. So let's go to question 8. This is on differentiable functions. A function f is continuous, differentiable and strictly decreasing on the interval 2.5 to 5. You are given these values. Estimate f-4 and f-4.8. So using Lagrange's mean value theorem, f-4 will be f of 4.6 minus 4 by 4.6 minus 4, f of b minus a by b minus a. So that will be 2.2 minus 3.1 by 0.6, which is minus 1.5. Now f-4.8, 4.8 lies in this interval 4.6 to 5. So we will take it as f of 5 minus 4.6 by 5 minus 4.6. So substituting the values you get minus 1.75. The same question is f concave. Justify. The derivative of f is decreasing. So when it is decreasing, the graph is concave down. Estimate integral 2.5 to 5 fx dx with a Riemann sum using left endpoints. So integral 2.5 to 5 fx dx using left endpoints, it will be 7.6 into 3.2 minus 2.5 plus 5.7 into 3.5 minus 3.2 plus 4.2 into 4 minus 3.5 plus 3.1 into 4.6 minus 4 plus 2.2 into 5 minus 4.6. So you will get it as 11.87. Estimate the volume of the solid formed when f is rotated around the x-axis. So the volume is given by delta V is pi r squared delta x. So that is pi. R squared will give you 7.6 the whole square. Delta x is 3.2 minus 2.5 plus 5.7 the whole square. 3.5 minus 3.2 plus 4.2 the whole squared. 4 minus 3.5 plus 3.1 the whole squared, 4.6 minus 4 plus 2.2 the whole squared, 5 minus 4.6 will give you 66.7 pi. Okay, question 9 is on differentiation. H is twice differentiable and the table gives us the selected values of H. Which of the following is true? H has no critical point in the open interval minus 4, 2. Now H is twice differentiable, so H will be continuous in the closed interval minus 4, 2. So by Lagrange's theorem, there exists some C belonging to the open interval minus 4, 2 such that H dash C is H2 minus H minus 4 by 2 plus 4. And H of 2 is 24. H of minus 4 is minus 36, so you get it as 24 plus 36 by 6 is 10. So B holds because H dash x equal to 10 for some value of x in the open interval minus 4 to 2. The next question is on differentiation. Which of the following functions is continuous at x equal to 0? We start with fx is sine 1 by x, where x not equal to 0, 0 when x equal to 0, limit as x tending to 0, sine 1 by x does not exist. So you rule out 1. B will be actually 1 when x not equal to 0, so limit as x tending to 0 of fx is 1, which is not equal to f of 0, which is 0. So B does not hold. F cannot be continuous at x equal to 0. If you look at C, limit as x tending to 0 mod fx will be limit as x tending to 0 mod x sine 1 by x, which is less than or equal to 0 because you have an x here. Mod AB is mod A into mod B, and what is 0? 0 is f of 0. So f is continuous at x equal to 0. And what about D? D will be 1 plus 1 by x. So limit as x tending to 0, 1 plus 1 by x does not exist. So we are asked for which of the following functions it's continuous. So it's continuous at A, at C. So it is option C. Next is on differentiation, L'Hopital's rule. Fx and gx are twice differentiable functions and the table shows the value of fx and gx and their first and second derivatives at x equal to 1. Find limit as x tending to 2 times fx minus 6 times gx by 4x squared minus 4 e raised to 3 into x minus 1. So substituting the limits, 2 times f of 1 is 1 minus 6 times g of 1 is 1 by 3 by 4 minus 4, which is 0 by 0 form. So by L'Hopital's rule, this becomes limit as extending to 1, 2f dash x minus 6g dash x by 8x minus 4 e raised to 3 into x minus 1 into 3. And now when you substitute, your f dash 1 is 0, g dash 1 is minus 2, and you get 8 minus 4 into 3, 12. So the answer is minus 3. So we have gone through a few questions of AP Calculus. I hope you have understood it. Stay tuned in for more and do subscribe.